This question is about hemoglobin's function as carrier of oxygen from lungs to the peripheral tissue. And while going back, hemoglobin carries protons from peripheral tissues to the lungs. Basically, this concept is explained by what is called as Bohr effect. So the question is about this question is basically about certain factors which will shift the oxygen dissociation curve towards left side or towards right side. Note that the factors which will shift oxygen dissociation curve towards its right side, they will try to keep hemoglobin in its T state or tight state or taut state. Whereas the factors that they will that they are keeping oxygen dissociation curve towards left side are factors which will move oxygen dissociation curve towards left side. They'll try to keep hemoglobin in its relaxed state. Okay, so now the question is about which all the factors help to release oxygen from hemoglobin at peripheral tissue level, and which one of the following do not result in a right shift of the oxygen hemoglobin dissociation curve. The question is which factor do not result in right shift in oxygen dissociation curve. Basically, you really need to rule out which is the factor which is shifting oxygen dissociation curve towards left side, basically, which do not result in a right shift of oxygen dissociation curve, indicating that this factor the factor that you are going to identify, it should be shifting oxygen dissociation curve towards basically left side. Okay, now the first option, increase in body temperature. Basically, increasing body temperature will keep hemoglobin subunits in its relaxed state, so that will basically help in the release of oxygen. And so anytime whenever there is increase in the body temperature, that's going to release the oxygen, so it's going to keep it in T state, so it means it's going to shift it towards right side. Now increasing muscular activity. Whenever the muscular activity is increased, basically there will be increased production of carbon dioxide, because TCA cycle will be running at a faster rate, and increased carbon dioxide, so basically it's going to diffuse into RBCs and combine with water to make carbonic acid by carbonic anhydrase enzyme, and carbonic acid is dissociated into bicarbonate and the protons, and the protons will go and bind protonate histidine residues, and thereby there will be formation of ionic bridges or salt bridges that will basically keep the hemoglobin in T state, and that helps to release oxygen from hemoglobin molecule. So that is basically moving hemoglobin into T state, so releasing the oxygen, so that will shift the oxygen dissociation curve towards right side, so it is also not a correct choice. Now the third one, decreasing BPG or DPG. So BPG is 2,3-BPG, 2,3-bisphosphoglycerate. So 2,3-bisphosphoglycerate, when it is present at high concentration, so it's going to bind with the positively charged pocket which is present in between the beta globin subunits. Okay, by forming a salt bridges between this positively charged pocket, so basically BPG, when it is interacting with hemoglobin molecule, it's going to keep hemoglobin in its T state, again helping in the release of oxygen. So when its concentration is decreased, so its effect on hemoglobin will be decreased. That will basically move the oxygen dissociation curve towards left side, keeping hemoglobin in its relaxed state. So this particular choice seems to be correct answer at this point of time. Now going from sea level to a mountain peak, option D. So when person goes from sea level to the mountain peak, so at the mountain peak basically there will be decrease in partial pressure of oxygen. So to adapt to this particular situation, our body RBCs will try to increase 2,3-bisphosphoglycerate, and increase in 2,3-bisphosphoglycerate try to keep hemoglobin in its T state, thereby helping in the release of oxygen. That's why it's going to shift the oxygen dissociation curve right side, so it's not a correct choice. Now increasing carbon dioxide. As I explained before, increase in carbon dioxide is going to increase protons by forming carbonic acid, which is going to break down into proton and bicarbonate. So increase in carbon dioxide indicates increased protons. So that's why increased protons means it will try to keep the hemoglobin in T state. So shift the curve towards right side. So that's why this choice is not correct. Now increasing H plus concentration. Again, as I explained in option E, so increase H plus ion means there will be protonation of histidine residue. So that's why hemoglobin will be getting into T state. So T state of hemoglobin means it is right shift in the oxygen dissociation curve. So that's why it's not a correct option. Now the final option G, that is decreasing pH. Decreasing pH means it is increasing H plus ion concentration. Again, it's protonation of histidine residue. So because of that, there will be T state stabilization, right shift in the oxygen dissociation curve. That's why it's not a correct choice. So ruling out all the other choices, so the appropriate choice for this particular question, which do not result in right shift in oxygen hemoglobin dissociation curve, is decreasing 2,3 bisphosphoglycerate, because it's going to shift the oxygen dissociation curve towards the left side.